Alright, so another video where I'm going to solve another problem. So we are given all of these 1, 2, 3, 4 trigonometric function, trigonometric function, and we want to determine the domain, and we want to find the zeros of the function, and then we want to find the inverse of the function. So when it comes to finding the domain of a function, here we need to look at of a trig function, we need to look at what is happening inside of the parentheses. Normally, the domain of a arcsin function, so an inverse trig function, goes from -1 to 1. So what I'm going to do is that I'm going to take what is happening inside of the parentheses here and substitute it for the x that I have in this equation and solve for the x value for which this restricted domain will work. So I'm going to go ahead and do that. Since my equation is f of x is equal to pi over 3 minus sine inverse, which is the same as arcsin, sine inverse of x minus 1 over 2. So here in this case, I'm going to take what is happening inside here and substitute it for my x value here and solve for x. So now what I get is -1 is less than or equal to x minus 1/2, which is also less than or equal to 1. I'm going to add 1/2 on both sides. So I'm going to be left with -1 plus 1/2 is less than or equal to x, which is also less than 1 plus 1/2. So here in this case, I will end up with 1/2 because -1 plus 1/2 gives me 1/2 is less than or equal to x, which is less than or equal to, here I'm going to add those two, I'm going to end up with 3 over 2. So this is my domain for this function that was given. Now, the second thing they're asking us to do is to find the zeros of the function. Just as the entire sentence says, the zeros of a function is where the function is equal to 0. So basically what we're trying to find is what values of x will make this whole function here equal to 0. So what we're going to do is we're going to set this whole function to be equal to 0. So I'm going to do it right here. I'm going to have 0 is equal to pi over 3 minus sine inverse of x minus 1/2. And I'm going to be solving for x. First step, because I don't want to deal with negatives, I'm going to bring this negative sine inverse of x minus 1/2 on the other side. So what I'm going to have is sine -1 of x minus 1/2 is equal to pi over 3. Now, I want to get rid of this sine inverse and just be left with x minus 1/2. So there's a rule in math that we have, which is sine of sine inverse of x is equal to x on a restricted domain, of course. And the same thing goes with cosine inverse, of course, of x will also give me x on the restricted domain. So what I'm going to do here is I'm going to go ahead and take the sine on both sides. So I'm going to have sine of what is happening to the right and what is happening to the left. So I end up with now x minus 1 over 2, because sine of sine inverse of x 1/2, this whole thing is just the same as our x in this equation, right? So this will give me this will be x minus 1/2 is equal to sine of pi over 3. Now, to solve for x, I need to know what is the exact value of sine pi over 3. And when I look at my unit circle from memory, I know that sine of pi over 3 is equal to square root of 3 over 2. So I can substitute it back here and continue solving for x. So I have x minus 1 over 2 is equal to square root of 3 over 2. If I want to solve for x, I can bring 1/2 on the other side. So this will give me x is equal to square root of 3 over 2 plus 1/2. We can stop there, or you can simplify further and just write x is equal to square root of 3 plus 1 over 2. So this is this value of x. If I plug it in our function, our trig function here that we have, this will give me 0. This will return 0. Now, I'm going to continue and find the inverse of the function. So, to find the inverse of the function, you can either solve it one way or another. The way I usually solve it is the following. So if I'm given an equation, I'm going to say, first of all, I'm going to change my variables. I'm going to say let f of x equal to y, because it's simpler for me to work with y rather than working with f of x. I think it's usually more appealing. So then our equation now becomes y is equal to pi over 3 minus sine inverse, of course, never forget the inverse, of x minus 1/2, right? So when we talk about the inverse, what basically we're doing is that we're changing the input and output, we're switching them. So what was supposed to be the input here was x, and y was supposed to be the output. Y was supposed to be the outputs. Now when we're doing the inverse, we want to make now that we want to say x is going to be the outputs values and y is going to be the inputs. And one of the way you can do that is you can immediately try to solve for x here. But what I like to do, because I always like to work with y, I'm going to change those two. I'm going to change the position and try to solve for y, which is still the same as solving for x in this case, where you find now x is becoming your inverse function. So I'm going to rewrite this way. I'm going to say x is equal to pi over 3 minus sine of sine inverse x minus 1/2. Sorry, y minus 1/2. I just made a mistake again. So y minus 1/2, because I'm switching those two. I'm now trying to solve for y. So once again, I can bring pi over 3 on the other side. So I have x minus pi over 3 is equal to negative sine inverse of y minus 1/2. So next step is I want to get rid of this negative. So I'm going to divide the whole thing, so both sides, by -1. So what do I get? I get negative x plus pi over 3 is equal to sine inverse of y minus 1/2. Once again, I want to get rid of the sine inverse. And just as we did in the previous example, we know that sine of sine inverse, so sine of sine inverse of x would give me x. So I can come again and do it here, whereby I have, so I can take the sine on both sides. So I have sine of negative x, my apologies, plus pi over 3 is equal to sine inverse of y minus 1/2. This would give me, of course, sine of negative x plus pi over 3, which is equal to what is inside of here because of our rule that we have. So I end up with 1 sine minus 1/2. If I continue to solve for y, I'm going to end up with sine of negative x plus pi over 3 plus 1/2 is equal to y. So this y that we just found is our inverse function. So the way we represent inverse function is we would do y prime. Oh, sorry, y inverse. My apologies. So remember that we say that we wanted to make use of this. We wanted to say that f of x is equal to y. So now that we know what y inverse is, this is the same as saying f inverse of x is equal to sine negative x plus pi over 3 plus 1 over 2. And this is the answer that I wanted to get. And we can do more exercises where we can use cosine, where we can use sine, and other complex examples. But I'm going to stop here and do this one.